All right, ladies, we are back. And so at the end of the first video, I was sort of introducing a restriction. Now here is the formal definition. So let F be a function from A to B, and let D be a subset of A. The restriction of F to D is the function F, and then that bar is representing restriction, and then that tells you sort of what you're restricted on, equals xy such that y equals f of x and x is coming from D. All right, so that's the definition of a restriction. When we do examples, I think it makes more sense if that definition is a little confusing. If G and H are functions, so this is sort of in addition to that definition, if G and H are functions and G is a restriction of H, we say that H is an extension of G. Okay, and so let's look at this example below. So A is the set 1, 2, 3, 4. B is A, B, C, D. And G is the function that takes 1 to A, 2 to A, 3 to D, and 4 to C. Okay, because it's mapped from A to B. Now, if we say then G restricted to the set 3, 4, well, that would equal the set containing just 3D and 4C. Okay, you guys see that? Because when the first term, so when the input is 3, it goes to D. We have that, and then when the input of 4 has that. So on that, so this is G restricted to, so we're just restricted to those two elements. So that's why it just becomes this new function, right? It's a function. It's a subset of the original function, but it's also a function. And so hopefully that made sense. Now G restricted, the second one, we can look at G restricted to just the number 2, the set containing 2. Well, that will just be 2A. Okay. And then finally G restricted to A. Well, that's just going to give you back out G again, right? Because it's all the elements. Okay, so hopefully that made sense. All right, I want to give you one more. I think this is the last definition. Then I'm going to do a couple examples with you all. All right, so let F go from the reals to the reals be a function whose domain includes some interval I. We say F is increasing, and you actually should know this. This is from Calc 1 on I, and no, this is actually from Pre-Calc. I'm sorry, I just taught this in my Pre-Calc 1 class a few weeks ago. F is increasing on I if and only if for all x, y belonging to I, if x is less than y, then f of x will be less than f of y. That's if it's increasing. It's decreasing if and only if on I. If x is less than y, then f of x is greater than f of y. Okay, so let's look at a couple examples, and I think I'm doing 1 or 2 examples from your homework, so you are welcome. All right, let's look at this 5B. This is actually a fun one. I like doing this one. Okay, so we have 3 functions here, and these are in congruence mod. We have some mods going on, which I think they are cool to deal with, and hopefully you guys are understanding and liking these mods. If not, oh well. But so we have F is going from Z8 to Z4, and it's given by this function here. That's our F function. Then we have G, which is going from Z4 to Z8, given by that function. And then we have H, which is going from Z8 to Z8 and given by that function. So it says show that G composed with F of X equals H of X for all X in Z8. Now here's the thing. You might think, oh my goodness, we have to do a proof. We do have to do a proof, but the nice thing about this is that it's a finite number of elements. So if you have, and let me say, I don't know if I ever made this sort of announcement. If you have a proof and it deals with just a finite number of elements, and if it's not too extensive, you can just show that all those elements work. I think there was in section 4.1, actually in the homework, I think one of those problems was like that, where it talked about the primes and it was a fixed number of elements in a set, and you basically did the proof by showing that those numbers, you add those numbers to make a prime. I don't know. But anyways, so that's what we're going to do here actually. So in our solution, so let's see. I'm going to start it off, but I'm going to have you all finish it. So I'm not going to finish everything for you. Why should I have all the fun? All right. So this is what we have to do. In Z8, how many equivalence classes are there? 8. Very good. And they go, the main ones, the captains of the teams, like I like to talk about, goes from 0 to 7, right? So all we need to do is check each of those numbers and show that this left-hand side will equal this right-hand side. So I'll do a couple with you, and once I start them, I guarantee you guys will get it. All right. I was going to color code. I'm not going to color code. I color coded the functions, but I'm just going to write them straight out. Let's see, what color haven't I guess I'll do green. I'm not a big fan of green, but we'll do that. Okay. Anyways, I'm procrastinating now. So G of F of, we're starting from F. So F, we know we're in mod 8. So we start from 0. Well, we just do the operation. Well, F of 0 in mod 8 becomes G of 2 in mod 4, right? Hopefully you guys see that. I'm just using that function right there, that operation for F. Now we go to our G function, and G equals G of 2 in mod 4 will become, oh, I can drop it now. It's just going to become 4 in mod 8. Since 4 is less than 8, it's one of the remainders, so that's simplified. Well, we have to show that this is going to equal H of 0 in mod 8. And what do you know? H of 0, if we look at this H function, it becomes 4 mod 8. Okay, so that checks off. So we just showed that the left-hand side equals the right-hand side. That checks off. Let's do G of F of the equivalent class of 1 mod 8. And that's all you have to do up from 0 to 7. That's all you have to do. So I'm just going to do this one with you. In your notes, I want you to finish this off completely, but I'm just going to do these two because I think you have the hang of it after this. So this becomes, so first dealing with F, this becomes 3 in mod 4, right? And that becomes in G, that becomes 6 in mod 8. I'm going to do one more with you. So then, and 6 is between 0 and 7. So we're good. And so this is saying H of 1 in mod 8 should equal, well, what do you know? It equals 6 in mod 8. So it's the same. Let's take one more just to be okay, and then I'll have you finish 3 through 7. All right, so F2 mod 8, okay, equals, well, F of 2 in mod 8 will become G of 4 in mod 4, right? Well, what's G of 4? So we can keep it as G of 4 in mod 4 if we want, right? But what's G of mod 4 really? What's G of 4 mod 4? That's really 0. Good. So 0 mod 4, right? And that will equal, so 0 mod 4 of G is just going to give us 0 in mod 8. And so this is, let's check to see if H of 2 of 8 will give us 0 mod 8. Well, if we plug that in, 2 times 2 is 4, so that's going to equal 8 mod 8, which that equals 0 mod 8. So that checks off. If you're not clear, this is very important to get this, especially as you move on. If you're taking abstract algebra after this class, you deal a lot with mods and things of this nature. So make sure you understand this. Make sure you finish in your notes. I will be checking. Make sure you finish in your notes 3 through 7 to verify that this composition here will equal that side. All right, ladies. So we're almost done, I think. Yeah, just one more slide. We have this function here, f of x is equal to 4 minus 3x, with the domain being the reals, and A is given as the set containing 1, 2, 3, 4. Sketch or describe the graphs of, the first one is F with the restriction on A. So here, so you can either sketch or describe in words. Well, let's think about this. Well, this is the same as F restricted to the set 1, 2, 3, 4. So what that tells us is that although our domain is the reals, remember when you restrict it, it becomes a subset, which it is, right? The set containing 1, 2, 3, 4 is a subset of the reals. And so what would that look like? Graphically, it would look like what? It would just be points, right? You couldn't connect them or anything because they're discrete points. So we can say this would represent 4 points on the graph. Well, what 4 points? Those points are, well, you just plug in 1, 2, 3, and 4 into your function and get your outputs, right? That's all this is saying. So those points are going to be what? 1 goes to 1 when you plug that in. 2 is -2. Pause and see if you can do the other 2 and then unpause. Welcome back. All right. 3, -5, and then 4, -8. Okay, so that's describing in words. Let's look at the second one. So now we're restricted on the interval -1, 3. Okay, we're restricted to, I should say. We're restricted to the interval -1, 3. Well, what do you think that'll be? Well, since it's the brackets, that means you include -1 and 3. So what do you think you need to do? Well, let's evaluate f of -1. That's going to give us 4 minus 3 times -1, which is 7, right? So that's the point -1, 7. And then f of 3 is going to be 4 minus 3 times 3. So that's -5. So that's 3, -5. So what this is going to represent is actually a line segment. I won't draw it out in its entirety. And for sake of time, we'll just know that, okay, so this is 1, 2, 3. 1, 2, 3, 4, 5. Although that side it's not as even, so assume it's even on these sides, although it's not. And so wait, that's not even. This is not right. Okay, the beauty of technology is that I can pause and make it right. So I made it right now. So all this is representing, so -1 is 7, so I'm assuming somewhere up here. Oh goodness. The stylus doesn't want to act right. And then 3 goes to -5. So let's say somewhere right here. So graphically, since it says it's the first one we described in words, but this one we can graph. So this restriction, F restricted to this interval, this closed interval, is just going to represent a line segment from -1 to 3. Okay, so hopefully that made sense. Finally, our last thing we want to do is a proof, sort of combining that restriction with increasing. So this is saying show that f restricted to the interval, closed interval 0, 2 is increasing. Well, let's think about this. Since we're restricted to 0, 2, this is a piecewise function, right? Which part of the function are we restricted to? Well, since it's from 0 to 2, including both, we're restricted to, so this is the function, or this will represent the function just x squared, right? So we just need to show, so sort of in our proof, we need to show that f of x, which equals x squared in our case, is increasing on the closed interval 0, 2. Okay, and so proof, well, let x and y belong to 0, 2. And you can go back and see the definition. I'm sort of just following the definition to help me with my proof structure. All right, well, we need to show, do another show, that f of x is less than f of y. And that would mean that x squared is less than y squared, right? Well, since x is greater than or equal to 0 and x is less than y, okay, then x squared, oh wait, did I not suppose? Oh, I forgot to suppose. I'm sorry, that was my fault rushing. I think I said it but didn't write it. So suppose x is less than y. That's the part of the proof structure. Since x is greater than or equal to 0 and x is less than y, x squared is going to be less than or equal to xy. Also, since x is less than y and y is greater than 0, then x times y is less than y squared. Hence, so this is a little trick and you have to sort of practice this. So I'm rushing through this. Not really. Well, I am rushing through this for the sake of time because I don't want to go over. I'm trying not to go over 15 minutes. But I want you to go back and see sort of the little trick I played to show that x squared is less than or equal to y squared. I sort of manipulated this XY. I brought in this XY and manipulated to get what I wanted. And sometimes you have to, oh, that sounds like a real life situation. No, I'm sorry. Don't do that. But no, sometimes in mathematics and proofs, when you're doing proofs, you have to manipulate. Just like when we were doing induction proofs, you have to sort of bring in a form of zero or something like that. So a lot of times in proofs, and that's why proofs become difficult, because it's just like, well, where did you think to bring that in? But hopefully when you go back over this, it makes sense. All right, we are done. This will be your notes for section 4.2.